Welcome to month 1 of the DevOps Engineer track. Over the next 4 hours, we're going to do something concrete. Take a project that has no automation and give it a production-quality CI pipeline. By the time you're done, you'll have a real pipeline, not a toy, not a tutorial, something you'd actually ship at work. This month covers 3 fundamental pillars: writing robust bash scripts, managing code with a clean Git workflow, and expressing your build process as code in a CI system. These 3 things underpin everything else in DevOps. Here's how the 4 hours break down. Hour 1 is foundational. We cover bash strict mode and Git workflow concepts. Hours 2 and 3 are the heart of the session, hands-on building of a multi-stage CI pipeline. Hour 4 is where you demonstrate your work and critique each other's pipelines. The lab platform is the BISTEC Mart catalog service, a FastAPI Python application with tests and a Dockerfile already in place. GitHub Actions is the primary CI platform, but if you're on GitLab or Jenkins, the concepts transfer directly. 5 things you'll walk away with today. First, writing bash scripts that don't silently swallow failures. The strict mode pattern changes how you think about scripting permanently. Second, understanding trunk-based development and why short-lived branches beat long-running feature branches for teams doing continuous integration. Third, authoring a real multi-stage pipeline, lint, test, build, publish, as code you can version and review. Fourth, handling secrets and catching safely, 2 areas where teams leak credentials or waste minutes every day. Fifth, diagnosing failures locally with ACT instead of waiting for the CI runner. These are skills that compound. A solid bash foundation makes pipeline debugging 10 times easier. The lab runs entirely on your machine via Docker Compose. No cloud account needed. Gitia gives us a self-hosted Git server. ACT lets us run GitHub Actions workflows locally. We have optional GitLab and Jenkins containers for platform comparison. Setup is 4 steps. Install Docker Desktop, install ACT, install shellcheck, hadlint and yamlint, then run Docker Compose up with the Gitia service. Gitia's first run wizard creates your admin account. Verify that ACT and shellcheck both respond with their version numbers in your terminal before moving on. Every serious bash script should start with 3 flags. Set, E exits immediately on any error. Set, U treats unset variables as errors. A missing variable becomes a failure, not an empty string that causes subtle bugs downstream. Set, O pipe fail makes the whole pipeline fail if any stage fails. Not just the last one. That 3rd flag is the one teams forget. Without pipe fail, a command that pipes into another can fail silently, and your script keeps going as if everything was fine. With pipe fail, a failing stage is caught immediately. Adding ifs set to new line and tab prevents word splitting on spaces in file names. Together, these 4 lines turn bash from a fragile glue script into something you can trust in production. The trap command registers a cleanup function that runs no matter how the script exits: normal exit, error exit, Ctrl-C, or sigterm. The pattern is: create a temp directory, register a cleanup function that deletes it, and trap that function on exit, int, and term. Without a trap, a script that fails halfway through leaves temp files, partial state, and sometimes a broken environment. With a trap, cleanup is guaranteed regardless of how the script ends. Idempotency means running the script twice produces the same result as running it once. This is a CI superpower. If a deploy step is idempotent, retrying after a flaky network failure is safe. Design every script around this principle from the start. Trunk-based development means everyone commits to main frequently, ideally daily or more. Short-lived branches live less than a working day. This is the opposite of Gitflow's long-lived feature branches, and it's what enables true continuous integration. If branch is live for a week, you're not integrating continuously. Conventional commits give your commit messages structure: feat for features, fix for bug fixes, core for maintenance, docs for documentation. This isn't cosmetic. CI can read commit types and make decisions automatically. A feat commit can trigger a minor version bump. A fix commit triggers a patch release. Annotated, signed tags close the loop. They give you an immutable audit trail of what was deployed and who authorized it. Branch protection rules on main are your safety net. Required status checks mean no pull request can merge unless lint, test, and build all pass. Linear history means no merge commits, cleaner git log output, and simpler bisects when something breaks. Signed commits require GPG or SSH signing, so every commit on main is probably from a known author. Codeowners lets you declare path-based ownership. The infrastructure team reviews changes under the infra directory. The application team reviews the app directory. This builds knowledge transfer directly into the review process. Admins can bypass these rules, and that bypass path needs to be documented. Make it visible and review override usage regularly. The bypass should be an emergency door, not a routine shortcut. 5 principles underpin every good CI pipeline. Reproducible. Pin every dependency. Actions by SHA. Docker images by digest. Language versions in a lock file. Fast feedback. Run cheap checks first. Lint before test. Test before build. If lint fails in 30 seconds, don't make developers wait 8 minutes for the build to fail. No secrets in logs. Use platform secrets and mask all output. A credential in a CI log is a credential breach. Catchable. Key catches on lock file hash, not branch name. Branch keyed catches are poisoned by any branch and don't share across pull requests. Auditable. The pipeline file goes through the same review process as your application code. No direct edits to main. For the hands-on portion, you're stepping into a real scenario. You've joined BISTEC as a DevOps engineer. The BISTEC Mart catalog service has 120 unit tests and a Dockerfile, but CI today is a developer running pytest manually and copying files to a server. The pain points are concrete. Broken main happens roughly every week because developers forget to run tests. The deploy script is 400 lines with no error handling. It swallows failures silently. Secrets are committed to the repository in a production env file. No one can tell which container in production matches which git commit, and only 2 people know the full deploy procedure. Your job is to fix all 5 of those problems by building a proper CI pipeline. The non-functional targets are: pipeline completes in under 8 minutes on a cold catch and under 3 minutes warm. The container image is under 200 megabytes, and 0 secrets appear in the pipeline logs. The pipeline has 4 stages gated in sequence: lint, then test, then build, then publish. Lint catches style and security issues in under a minute, so the heavy stages don't waste time. Test runs the full pytest suite with coverage. It must reach 70% to pass. Build constructs the Docker image with Docker builds and a layer catch mount. Publish pushes the image to the Harbor registry, but only on main. The gating is essential. Test depends on lint. Build depends on test. Publish depends on build. A failure at any stage stops the pipeline. Publish is additionally gated on the branch being main, so feature branches build the image to confirm it compiles, but never push to the registry. The lint job demonstrates the full pattern. You pin the checkout action by its full commit SHA, not a floating version tag. You set concurrency to cancel superseded runs on the same branch, so if you push 2 commits, quickly the first run is canceled, and only the latest runs. Then you run 4 linters in sequence. Shell check audits every shell script. Hadlint lints the Dockerfile. Yamlint checks the pipeline file itself. And rough catches Python style and import issues. The concurrency block prevents a queue of stale runs from consuming runner capacity. If you push during a running build, the old build is cancelled immediately. Pinning by SHA isn't paranoia. GitHub action tags are mutable. The same tag can point to a different commit tomorrow. The SHA is your guarantee of reproducibility. The test job introduces 2 important patterns: matrix builds and dependency catching. The matrix strategy runs the tests against Python 3.11 and 3.12 in parallel. If a new Python release breaks something, you find out before deployment rather than after. The cache key is constructed from the operating system and the hash of the requirements file. This means changing requirements invalidates the cache, which is exactly the right behavior. A restore key without the hash gives a partial catch hit when no exact match exists, still faster than a cold install. A common mistake is keying catches on the branch name instead. Branch catches don't share across pull requests. You get cold installs constantly, and stale dependencies from one branch can appear in another. Always key on the lock file hash. The build stage uses Docker builds with catch from and catch to pointing to the registry cache. This means the layer catch persists across runs in the registry itself, making warm builds dramatically faster than rebuilding from scratch each time. The image tag is the full git SHA. Any container running in production can be traced back to the exact commit that produced it. This solves the traceability problem directly. No more guessing which code is deployed. The publish job has 2 gates, an explicit dependency on the build job, and a branch check that restricts publishing to main only. Feature branches build the image to confirm it compiles. They never push the registry. Secrets belong in the platform secrets store, and never in the pipeline file or the commit history. The correct pattern for Docker login is to pipe the password through standard input using the password stin flag. This means the secret never appears in the process list or shell history. After a pipeline run, you can verify cleanliness by searching the log for common credential keywords. If that search returns anything, you have a leak to fix. Matrix fail fast set to false means all matrix versions run, even if one fails. You get complete information about which Python versions break. With the default fail fast true setting, a failure on one version cancels the others, hiding whether they would also fail. Local reproduction with ACT and a named job flag runs any pipeline job on your machine. This is how you diagnose CI failures without pushing experimental commits to trigger the remote runner. There are 4 deliverables, each worth 25 points. The first is the hardened deploy script using strict mode, trap-based cleanup, and demonstrated idempotency. Shell check must report no findings. The second is the Git workflow document covering your branching model, conventional commits with examples, branch protection screenshots, a codeowners file, and a PR template. The third is the pipeline file itself along with evidence that it runs, such as the ACT list output or a pipeline execution graph. The fourth is the operations runbook covering failure modes, local reproduction steps, cache and secrets documentation, and a performance budget with recent measurements. Passing score is 75%. Exceptional work, scoring 90 or above, means a pipeline you'd actually submit in a pull request at a real company. 6 offline milestones to complete before month 2. First, migrate a personal project to a 4-stage CI pipeline using what you built today. Second, add a release workflow that creates a signed Git tag and a GitHub release on tag push. Third, replace any floating action version references with pinned commits. Fourth, add dependabot or renovate to keep CI dependencies current. Fifth, read the first 10 chapters of the Phoenix project. It provides context for why these practices matter organizationally. Sixth, write a one-page comparison of 2 CI platforms based on the same lab. Key resources are the GitHub Actions documentation, the GitLab CI/CD reference, the shellcheck wiki, the trunk-based development guide at trunkbaseddevelopment.com, and the OS CI/CD Top 10. That last one is worth reading early, because CI pipelines are a frequent attack target. Month 2 covers containerization with Docker, multi-stage builds, image hardening, and the Harbor registry you pushed to today. 4 things to take away from today. Strict mode makes scripts safe. Set UO pipe fail is not optional for production bash. Trunk-based development enables continuous integration. Long-lived branches are integration debt that compounds. Pipelines are code. They deserve the same review, testing, and dependency pinning as your application. And SAA pinning closes the reproducibility loop. If you can't reproduce a build exactly, you can't safely fix it. You've built something real today. Bring that pipeline to month 2, and we'll make the containers it builds production grade.